All right, and we're recording. Good morning, students. This should be Monday of week 3 of online learning. Okay, just a couple of announcements before we begin. There will be a learning activity after this video. It will be posted. Retake times, you need to sign up using Google Forms. I'll send that link and put it into the week 3 on top of the module as well, okay, for the sign up. So if you need to retake or make up even for last time's PC, you'll need to sign up, okay, and go to my office hours for those particular times. But this week, I'm going to try something new. We're actually going to be using we're going to use conferences in Canvas now. Okay, we're going to use conferences in Canvas now. I'll send another email out about this. But I'm trying to get rid of YouTube mainly because I noticed, and just a couple of comments from some students, that it's a lot easier using conferences on Canvas. And so I think what I'm going to do is start using that. I know that Ms. Cherokino's using that, and I know that some other teachers as well are using conferences for Canvas, okay? So I'm just going to switch over that from YouTube. But the hours will still be the same this week. We've got Tuesday, Thursday for those times. Go ahead and look at those. I'm thinking about adding another time. So if you want more time, maybe on Wednesday, let me know. We could schedule that time, okay? But other than that, let's get started with the lesson, okay? We got a couple things to learn. A lot of new stuff with geometry, right? Okay, so let's go ahead and do this do now first as a good warm-up from what we learned last week. I need to find the perimeter of this parallelogram. Okay, remember parallelogram, we have 4 different sides connected to each other, right? Looking at this in the kind of my eye, I can see that's trapezoid, but I actually don't know if A and D and CB, those two diagonal sides, are the same. So I need to double check with that, okay? But we can easily count these horizontal sides. Again, we're trying to find the perimeter of this parallelogram. I can count it as, let's get started. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And again, I don't know what A to D is, and I don't know what C to B is, okay? So I'm going to double check with that. So I was trying to find A to D. I'm going to use my distance formula, which should be parentheses -2 minus -5 squared plus 2 minus 2 squared. That should give me the square root of -2 plus 5 is 3 squared, plus 2 plus 2 is 4 squared, right? And that should give me the square root of 9 plus 16, square root 25, which I know is that's 5, okay? So from A to D is 5. Let's double check with, let's say, B to C. I don't know exactly if it's going to be the same, but let's just double check, right? So I got 5 minus 8 squared plus 2 minus -2 squared. That's the same thing as saying -3 squared plus 4 squared, which looks like the square root of 25. So that also is 5, okay? So those are the same. Those are congruent to each other. Let's add those all up to get the perimeter. My perimeter is going to be, that's 10, 23, 30. That's my perimeter, okay? Hopefully that's a good warm-up for y'all. Today we're going to learn about congruent figures. We're going away from area and perimeter, and now we're going to look more into angles and lines, okay? So by the end of this lesson, you should be able to identify the congruence of polygons by corresponding sides and angles, okay? What's more important is the word congruence. I'm going to use that word a lot. We're going to keep practicing using that word, okay? But congruence basically means same, right? Not equals. I guess you can say equals, but let's just say, to be more exact, congruence means same, okay? Same, even similar. All right. I should mention first, this is going to be a lot of definitions. I'll try to get through this lesson a little bit quicker, and I'll give you little hints and bits, right, that I believe I should cover to help you learn this, all right? But I need you to know that a congruent figure is basically when you have the same shape and size, right? So not for everybody, but my left hand is going to be congruent to my right hand, right? Ideally, if you look at my hands, they should be congruent to each other. That's the ideal. Not always in real life, but that's the idea here. So with congruent figures, you have 3 different things. You have, we call these rigid transformations. You've learned this in 8th grade as your slides, when you're moving a shape around, a flip, or a rotation, right? Your geometric shape or your figure is moving in, right, maybe certain degrees. But again, all these When you meet all these needs, such as your side, flip, rotation, it's a symbol. We call this congruence, okay? So when you have two different shapes, two triangles, for example, they have all these three components into it, but essentially they should look the same. Therefore, we call them congruent figures, okay? This is a little bit wordy with the acronym here, but we can cover that. So now we have the definition of congruent polygons. Okay, all that is two polygons are congruent if and only if. Okay, if and only if means it has to be the case, right? If and only if their corresponding parts are congruent to each other. So if I look at these two polygons, we got A, B, C, D, and H, G, F, E, right? So those two, if they are corresponding parts, if they're corresponding parts, so maybe you can see here we got, maybe the side A to B and F to E. If those corresponding parts are congruent, then we know this is a congruent polygon, okay? Acronym for that, I don't really know how I feel about this, but this is something that my mentor kind of left with me, is the CPCPC. I'll say again, the CPCPC. The CP corresponding parts of congruent polygon CP are congruent, the C, okay? So corresponding parts of congruent polygons are congruent, okay? They're similar to each other. So let's use this more of an example. All right, I'll talk about this, but I want you to pause as well to kind of process all this. This is a lot of stuff. I understand geometry is a lot of words, right? And it does with figures and geometry with geometric shapes and all that. But we need to kind of take it slower and make sure we're processing all this, okay? So pause this video if you need to. But here I have two polygons from the last slide. If I say they're congruent, so if ABCD is congruent to EFGH, then what I can say is, well, all the sides, let's say, for example, A to B, I'll do this in green. I'll do this in green, sorry, not blue. AB is congruent to FE, okay? The only thing you see here is that it looks like it's flipped from each other, right? There is a reflection going on here. But if these two polygons are congruent to each other, then I know that all the sides, every single size of those are going to be congruent to each other, right? The corresponding sides, so the sides that look pretty similar from each other, but just placed differently, right? So those are also congruent to each other. If I was looking at the angles, so I say AE, again, this symbol we call angle. So I say angle A and angle E. Let me just circle those. Do that for angle. Okay? Because this polygon is congruent, assuming it's congruent, right? We can say those two angles, those corresponding angles from each other, are also congruent to each other. And same goes with all the other sides, same goes with the other angles, okay? Go ahead and pause this video, double check if I'm right here. Again, this is part of the processing. If you just believe me, that's fine, but I want you to process this, so please pause this if you're confused with all this wording because it's too much right now, okay? Another definition, we could say at each of those points, at A, B, C, D, and H, G, E, or H, G, F, E, those are called vertex points, okay? That's just a little wordage that you'll learn next year more about using vertex, but that's just basically a point where two lines or line segments meet, okay? That's a vertex point. So I know that those vertex points are also congruent because they create those congruent angles, okay? Again, there's a lot of definitions here, okay? So please take some time to go back and pause the video if you need to, all right? But the next part is we got looking at their angles. We're talking about vertical angles. So basically, vertical angles are opposite angles of intersecting lines, or line segments are congruent. So if I have here an intersection, maybe intersection means cross, right? Then I can see the vertical angles, literally the top and the bottom, are congruent to each other, okay? Because vertical angles are congruent. Again, if I look at those left and right points, or those left and right angles, those are also congruent, okay? This is because of the line segments. When you do any kind of intersection, right, doesn't matter how much you bend it, you'll always have that vertical angles are congruent thing, okay? Keep that in mind. Vertical angles are congruent. I remember in geometry, my teacher would just always yell that, and he's like slamming on the whiteboard, like, vertical angles are congruent, vertical angles are congruent. He'd also make like random awkward grunts in the middle of class because they work for some reason, help us learn. But anyways, so vertical angles are congruent. Next two things I want you to understand are supplementary and complementary angles, okay? Look at supplementary. Supplementary angles are when you have, again, a horizontal line, but you have a line that's kind of bisecting or going through it, right? Well, that creates the two sums of those two angles that are created by that line going through that horizontal line. The sum should be 180 degrees, okay? So go ahead and look at angle 1 and then angle 2. If I add those two together, that creates 180 degrees, right? Remember, with 180 degrees, that's half a circle, or that's going to create a horizontal line, okay? And then obviously with 360 is when it goes all the way, right? Now, if I create an angle whose sum is 90 degrees, we call that complementary. So if you look here, I have angle 1 and I have angle 2. Well, angle 1 plus angle 2, when they add together and make 90 degrees, when they make 90 degrees, that means it's complementary, okay? Supplementary, 180. Complementary, 90 degrees, all right? 90 degrees or a right angle, okay? We're actually almost done with this lesson. Isn't that pretty good? Got some more definitions for you. Hopefully you're feeling okay about it. We're going to keep practicing it, okay? Next point is transversal lines, okay? Basically, all we have with transversal lines, this mostly happens when you have two parallel lines, okay? But transversal is a line a line intersecting two or more lines in a plane at different points. Lines don't have to be parallel. So if I'm looking at that transversal line, okay, go ahead and look at the first figure here, right, where you have two parallel lines, but the transversal line would be those more slanted parts of the shape, right? Same thing goes when we go to the next one. That looks like a polygon, looks like a parallelogram, but those transversal lines are the angled parts of it, right? And then looking at the square, the vertical part is transversal. Now look at this last figure. The transversal line, you have two parallel lines, it looks like, right? But then you have a transversal line that goes right through it, okay? We're going to look at this and kind of think about the little details with it, all right? But let's go into that. So I'm just going to go through definitions first, and then we can go over, actually, I'm going to go over what it looks like, and then we're going to go over to like more examples that apply to that definition, okay? So given that I have two parallel lines, and I get cut by a transversal line, okay, then we have the following. There's four of them. First one is the corresponding angles are congruent to each other, okay? We'll talk about this, but again, I want you to understand these words. Corresponding angles, they'll be congruent to each other. Remember, corresponding is when they're on the similar side of things, right? They're in the similar position. That's what corresponding means, okay? Second one is alternate interior angles. When it alternates, we're going to have one on one side and another on the other side of the transversal line, okay? We'll talk about this. But if we have alternate angles, interior angles, they can also be congruent with transversal lines. Okay, we call this transversals. Second one is you have consecutive interior angles, which is the inside interior angles. We'll talk about those. And then we also have alternate exterior angles. Okay, just to kind of briefly go through it, let's go through an example. Okay, so here we have corresponding angles. Remember, corresponding means it's kind of in that same position, right? If I look at here, my corresponding thumb would be my right thumb right over here, right? This is my left thumb. Okay, it's mirrored, so it kind of looks like this is the left, this is the right. But this thumb is corresponding to this thumb, right? They're both thumbs, those are corresponding, similar to each other. Same thing goes with these transversals, okay? So if you look here, we have angle 1, 2, 3, 4, and then 5, 6, 7, 8, right? Notice how those are two parallel lines. Those two parallel lines, right, are getting cut up by a transversal line. So each corresponding angle are going to be the same if we have two parallel lines and a transversal line going through it. So I can say that angle 1 is congruent to angle 5, okay? Go ahead and pause and try to see what would be the corresponding angle if I gave you 4. Okay, this should be 8. Are you kind of getting this? It's kind of in the same spot if you get cut right in half, right? This is basically saying I have two hands. Where are my thumbs at? My thumbs are right here. It looks more like this maybe. Does that look about right? Yeah, so if I was to find the corresponding thumb, it'd be right there. So the corresponding angle from 4 would be 8. For 2, angle 2 would be angle 6. and the corresponding angle for angle 3 would be 7. Okay, is that making sense? Again, corresponding, use your fingers. Okay, now let's look into alternate interior angles. Again, alternate is when it's going back and forth, right? Alternating, we have alternating numbers, alternating whatever, right? But now if I have the interior angles, which is if you have, again, the parallel lines, you got the parallel lines right here. The interior is everything inside, in between those two lines. Those are interior. And if they're alternating, then they're congruent, okay? So the alternating angle for this one with the two parallel lines, for angle 3 would be angle 6. And then what would be the alternate interior angle for angle 4? That would be angle 5, okay? Those are alternating from each other, meaning that even though they're not on the same side or the same little circle of angles, right? They're alternating because when you put them together, they still make that supplementary angle, okay? We'll do a practice on this, I promise. We got 2 more though. Next thing I have are consecutive interior angles, okay? Consecutive interior angles, again, interior angles mean the angles in between the 2 parallel lines. The consecutive interior angles is when you add them together and you create a supplementary number, right? A supplementary 180 degrees. Basically how I see this as, well, you have the transversal line. The consecutive interior angles are the interior angles between the 2 parallel lines, and they're on the same side of the transversal, right? So you see how I have a transversal line. I will do this in red, right? That's the transversal. So the transversal. And then on the same side is those 2 angles, 3 and 5. We add them together. We call those consecutive interior angles, okay? If you add 4 and 6 together, you also get consecutive interior angles, okay? This is all these little definitions. They're important. You need to remember that. So now I got alternate exterior angles, okay? Alternate exterior angles. So exterior means on the outskirts, not in between the 2 parallel lines, but on the outside of the 2 parallel lines, okay? On the outside of them. And it goes with that alternating again, meaning that one of the angles is on the left side of the transverse line and the other one's in the other side, right? That's what means alternate, when you have this transversal line and you have one on this side and one on the other side of it, okay? But those will be the same as well. They're congruent if and only if we assume that these are parallel lines, right? Okay, so hopefully you're feeling good about that. I feel pretty good about that. You can always go back to this video, rewind some things, maybe look some extra stuff up on Khan Academy. Maybe I'll put some more videos. I'll have to look for it. It might take a while, but maybe that'll help you out as well. But let's go into an example, okay? So now I got this example. A lot of stuff going on here, isn't it? So I can see that I have to find the missing values, and I need to also talk about how I know what those missing values are, okay? So when you have this situation, you have those 2 parallel lines in that transversal, you just have to look where the numbers are, right? Trying to figure things out. So I don't know any of those angles except that one, which is 35 degrees, okay? So I'm going to start with, 35 degrees. I know that B is going to be 35 degrees. So this is 35 degrees because of vertical angles, all right? So because of vertical angles, I know that's 35, all right? Well, if I was to try to find, let's say, F is also 35 degrees. Okay, so this is 35. And this is also 35. And again, I'm just kind of going around with this and just using the definitions I know and just, trying to put those together. So I know F is also going to be 35 because of exterior. I'm going to say exterior. This is alternating, right? So I can call this alternating exterior angles. There's also more ways to define these. But these are just some things I'm just pulling out from our definitions, okay? Okay, so if that's alternate exterior, I can look at D. Well, D has to be D plus 35 should give me 180 degrees, okay? Because of consecutive consecutive interior angles, okay? So 35 plus what gives you 180? Well, I know that 35 plus 145, so D has to be 145 degrees because of, we call it consecutive interior. Interior means between the parallel lines, angles. Okay, because you add them up, they equal 180. Okay, now we could figure some more stuff out, right? Well, if I look at D is 145, then I know C has to be 145 as well. Okay, that's 145 because of alternating. Is it interior or exterior? If you're thinking interior, then you are correct. Exterior, remember, interior means inside. Exterior means outside the parallel lines, okay? Okay, well, I also know A. What's A going to be, everybody? That should be 45 degrees because vertical angles. Okay, and then E, I can also say is 35 because of vertical angles. You could also say alternating interior angles. Okay, that's another one. So I know this is 35. I know this is 145. Whoops, E, I'm sorry. E is 35. And then G, you also know it's 145 because of vertical angles are congruent, or you can say that this is 145 because of alternate exterior angles. Okay, so that is how I'm going to find this, and this is how you find all those different angles, okay? It's a lot of stuff going on there, but again, trust me, go back to those videos, understand what's going on here, right? With congruence. Congruence basically means that if you have these situations, that these have to be the same, okay? I wish I had more examples, but I think the learning activity has a good amount. We can definitely go over that in my office hours, right? And then I can hopefully find some more examples for you, maybe through Khan Academy and some more learning activities through Khan Academy, okay? But what did we learn today? We learned that we can identify congruence of polygons by corresponding sides and angles. Okay, remember some of those definitions. Vertical angles are always what? They're always congruent. Okay, and I also know that if I have transversal line and two parallel lines, then I can look at four different things, right? I can look at the corresponding angles. I can look at the alternate interior angles, the alternate exterior angles, and the what was the third one? The fourth one, can't remember. The consecutive interior angles, right? When you're adding them together and make 180 degrees. Okay, so please don't forget to comment in the discussions. You're gonna have a lot of questions here. I understand. Hey, put your questions down. I'm gonna answer them and come check back with me once I answered them, okay, in the discussions. I totally understand. This is kind of hard. A lot of information, okay? But again, please come to my office hours. We could do the learning activity together. Feel good about it. I can answer your questions. That's Tuesday and Thursday this week. Please sign up for a retake if you want to retake that proficiency check or if you missed that day as well, okay? I'm gonna put that up as well. Remember, office hours on conferences and Canvas, okay? It will no longer be on YouTube. So sad. But other than that, good luck with learning. I will try my best to find more resources for you and make it a great day, right? Take care.